In this video, we're going to look at the final area of study known as sampling and estimation. To start off with, we're going to look at how this area of study differs from the other types of probability, and then we're going to explore some of the key questions that are asked in exams. For those who don't know me, my name is Chris Iannazzoni. I used to work as an engineer for a defence company, and I've since left that to start a career in tutoring. I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. At its core, sampling and estimation is basically an exploration into using larger sample sizes versus using smaller sample sizes. Take, for example, a coin toss. We know intuitively that our odds of getting a heads versus an odds of getting a tails is going to be 50-50. But if you only toss that coin 6 times, there's a possibility that you get 5 heads and only 1 tail. Why wasn't it a 50-50 split? Well, we didn't toss the coin enough times. This area of study defines 2 new terms to allow us to differentiate between using larger samples versus using smaller samples. The population proportion is defined as the total number of possible elements in the entire population that have the attribute we want, divided by the total number of elements in that population. We're looking on a global scale. The sample proportion is similar, but we're using a subset of that total population. We're only looking at a small sample of it, and it's defined using p hat. You can think of both of these equations as having the same generic equation, x over n, where x is the number of elements that have your given attribute, and n is the total number of possible elements in that scenario. The only difference is how large your sample size is, whether you're looking at a global scale or whether you're just taking a small subset of that. To demonstrate the differences, here's an example. A mathematics class contains 3 boys and 5 girls. A group of 4 students is selected randomly from that class, and that group contains 1 boy and 3 girls. The first question is asking us to calculate the population proportion of boys in the class. That means we have to look in the class, not in that small sample. There are 3 boys in a total of 8 students, hence the proportion of boys in the class is going to be 3 out of 8. The sample proportion only looks at the small subset, that sample that we took of 4 students. In that sample, there is only 1 boy out of a total of 4 students, so the proportion of boys in that sample, the sample proportion, is 1 out of 4. What we can see is that taking random samples isn't necessarily indicative of the true population proportion. The good news is that solving these sampling and estimation questions is actually identical to solving discrete probability questions. There's just one step we have to do at the start to convert it to an equivalent discrete probability. Consider this example here. There are 4 white balls and 6 black balls in a jar, and 3 are sampled without replacement. We're then asked to find the probability that p hat equals a third, where p hat represents the proportion of white balls in the sample. So, as I mentioned earlier, the first step is going to be to convert to an equivalent discrete probability. Well, this is where we're going to use our p hat equation. P hat equals x on n. We're told what our p hat value is, it's a third, and we can see that our n value is 3, since that's the sample size. All we have to do is rearrange for x. After a bit of rearranging, or just by observation, we can see that x equals 1. What this means is that probability of x equals 1 is identical to saying probability of p hat equals a third. This is now just a discrete probability equation, which we've done before. There are 2 main methods we can use from here. The first would be a counting methods approach, where we find the number of combinations that only have 1 white ball, and then divide through by the total number of possible combinations. So, if we need 1 white ball, that means of the 4 white balls, we're selecting 1, and of the 6 black balls, we're selecting 2. As for the total number of combinations, well, we have 10 balls in total, and we're selecting 3. If you need to revise how this works, then check out the counting methods video. I'll leave a link in the description for you. The other alternative is to just calculate the probability of each of the given combinations. So, white, black, 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 white, black, and black, black, white. Just remember that this is without replacement, so every time that you select a ball, the denominator is going to decrement. Sometimes you'll be asked to find a range of p hat values rather than a specific p hat value. Once again, we're just going to convert this statement to an equivalent discrete statement and then solve it as if it were just a discrete probability question. So we're just going to use that p hat equation again. And having used that, we can see that p hat less than or equal to a third is the same thing as saying x less than or equal to 1. If we recall our discrete methodology, all we have to do here is add up all the probabilities in the interval. So in this case would be x equals 0 added to x equals 1. We've already done x equals 1, so let's do x equals 0 now. X equals 0 means no white balls, or just 3 black balls. So all we're going to do is calculate the probability of getting a black ball, then a black ball, then a black ball. Once again, don't forget, this is without replacement. So every time that we take a black ball out of the jar, we're going to decrement the total number of balls in the jar, and we're also going to decrement the number of black balls in the jar. Now we have all the probabilities we need, so we're just going to add them all together and simplify. So solving probability equations with p hat in them is really no different to solving just regular old discrete equations. We just have to do one step at the start to convert our p hat value into an equivalent discrete value. If you found this video helpful and would like to see more, I actually have all sorts of additional resources available for free on my website. Just click the link in the description and you can access them here. And if you'd like my personal help, then consider signing up for the tutoring program. I offer the first 2 weeks free of charge so you can get a feel for whether or not this will be a good fit for you. Otherwise, I'll see you in the next video.